Okay, so if you look at CK12, you will notice that there is section 7.1, 7.2, 7.3. 7.25 is not in there, but it's covered in 7.2, and we just wanted to make sure you guys really understand it. So what we're going to do is we're going to go through here, and we're going to first see if we have a pattern. So this one is going to start as 3 is my exponent, and it's going to have it's going to have 2 to what power? So I'm going to have 2 to the third power, 2 to the second power, 2 to the first power, 2 to the 0 power, 2 to the negative 1, 2 to the negative 2, and 2 to the negative 3. Okay? Over here, it's going to be the same thing on the other side, except this one is going to have 3 as the base. So 3 to the third, 3 to the second, 3 to the first, 3 to the 0, 3 to the negative 1, 3 to the negative 2, and 3 to the negative 3. Now for the next part, you're actually going to probably need a calculator. I've got one here, and we're going to work through that. So I know that 2 to the third is 2 times 2 times 2, which is 8. I know 2 squared is 4. I know that 2 to the first is 2, and then 2 to the 0. So you probably don't remember that, but if you do plug it into a calculator, you end up with 1. So what is happening each time is you are getting 8, then you divide by 2, and you get 4, and then you divide by 2, and you get 2, and you divide by 2, and you get 1. So then if we take 1 divided by 2, this is actually going to be 1/2, and this is actually going to be 1/4, and this is actually going to be 1/8. Now this is going to come in handy later because you're going to notice that these are opposites. They're flipped. They're the reciprocal. But every single time we are dividing by 2. So that's kind of the rule that's happening here. All right, so on the next one, 3 to the third power is going to be 27. 3 squared is 9. 3 to the first is 3. If you type in 3 to the 0 on the calculator, try it. You do get 1. Now, if you type in 3 to the negative first on the calculator, you get a decimal, but it's actually, the decimal is going to be 0.33333 repeated, which we know is 1/3, which means this one is going to be 1/9, and this one is going to be 1/27. Again, it's the reciprocals on those. So negative exponents is what we're talking about. What happens with negative exponents is you get a fraction, okay? So ultimately, you're taking 4 to the third power, and we can't have a negative exponent because it's just like dividing repeatedly. So we're going to take that and we're going to move it. Anytime there's a negative exponent, I'm going to move it. So I move 4 to the third down to the bottom of a fraction. Well, I don't know what to put on the top. Well, if anything, this is over 1. So if I flip that, it becomes 1/4 to the third. Remember on this, it's you get a 3 and you get a 3. So what we end up having is 3 to the negative third over 2 to the negative third. Well, if that's the case, this is negative, which means we have to go up. And this is negative, which means we have to go down. I'm running out of room here. So this should be 2 to the third over 3 to the third. Okay? Notice, I'm going to rewrite this. Notice that these are 2 separate things. This is where I like to use highlighters or just to identify different areas. So this is one thing, and this is another. Okay, so if that is the case, what I'm going to do is I'm going to keep my 5 because nothing changes with my 5. If this is a division problem, I just take a -3 minus 10. Well, that ends up giving me a -13. Since I can't have a negative exponent, I move it down, and I end up with 5 over x to the 13th power. This, again, should all be review from last year for you. Okay, so the bases are the same. I just need to add them together. So I have 16 plus a -14, which gives me 2. So my base stays as 13 to the second power. This becomes Oh, it's the same problem. So we're going to write it out as like what, here's how I would do this. So you have 13 to the 16th over 13 to the 14th. So this is the same problem. I'm just showing you a different way to do it. So if I subtract, I could write it out in longhand, but if I subtract it, I'm going to end up with 13 squared anyway. Okay, so for this one, I've just gone through and I've highlighted the different colors for each thing. So I've got my 5 and my 3 is the same color. I've got my X and my X is the same color, and then my Y's are both blue. So I take 5 times 3, since that is a multiplication sign, and then I'm going to take, that would be a 1 plus a negative 10, which would be X to the negative 9th. And then I've got a negative 2 and a positive 8, so negative 2 plus 8 gives me 6, so that's y to the 6th power. Now I'm not done just because this pesky little x is negative. So if that's the case, I'm going to drop it like it's hot and drop it on down. So I've got 15 and y to the 6th both hang out on the top, where the x to the 9th goes to the bottom. And remember, when it goes to the bottom, it becomes positive. All right, so zero exponents, definitions of a zero exponent. Basically, I'm telling you anything to the power, anything to the 0 as a power is 1. So 15 to the 0 power is 1. This whole thing, since I would have to distribute out my 0 here and here and here, that would give me negative 3 to the 0, x to the 0, y to the 0. That would all just be 1. This, I would have to multiply my numbers together. So I'm going to multiply my 4 times my 3, and I get 12. And then if I add these, 10 plus a negative 10 is 0. I'm going to get 12 times x to the 0. Well, x to the 0 is 1, which ends up being 12 times 1, and that's 12. Okay, last one. What about 0 to the negative 9 power? Okay, well, I know I have to move it, so I put 1 over 0 to the 9th. Well, what is 0 to the 9th? That's a problem, because 0 to the 9th is 0. And anytime you have 0 on the bottom, it's like the dark hole, and it is undefined. All right, so fill out your definitions. So a to the 0, it says anything to the 0 power is 1. So an example, but why this works, go ahead and take some time and write 5 to the 2nd power, or 5 to the 2nd power. Well, if you write that out, it's 5 times 5 over 5 times 5. I can cancel all of those, and I get 1. So 5 to the 2 minus 2, which is 0, is the same thing as 1. All right, so the next one, a to the negative exponent. To rewrite a negative exponent as a positive, move it to the other part of the fraction. So if it's on the top, you move it to the bottom. If it's on the bottom, you move it to the top. So if I write out my example, I have 8 squared over 8 to the 4th, so that looks like 8 times 8 over 8, 8, 8, 8, 8. So I'm going to cancel these, and I end up with just 1 on the top, and then 8 squared on the bottom, or 64. Well, if I look at it this way, I can take 2 minus 4, which gives me 8 to the negative 2nd power, and we know that if it's to the negative 2nd, we have to move it to the bottom, or I divide and get a really messy decimal. And finally, I've got 1 over a to the n. To rewrite a negative exponent as a positive exponent, move it to the other part of the fraction. Notice these are the same. The only thing is this gets moved down, and this one, surprise, surprise, is going to get moved up. So it is a to the n is the reciprocal of a n. All right, that's all we have for today. Have a great evening, and we will see you tomorrow.